Hello, everyone. My name is Karen Hudson-Edwards. I'm a professor in sustainable mining at the Camborne School of Mines, University of Exeter in the UK. I've been asked today to give an overview of cobalt in circular economy. And I'm actually going to extend that to cobalt and other technology metals in the circular economy. I'd like to acknowledge my co-authors, Francis Wall, Eva Marquez, and Carolyn Pettit, who work with me on the Met4Tech project that I'm going to describe. Cobalt is a critical raw material as designated by the European Union and many countries, and it's also a technology metal. These are slightly different terms, but they basically have similar definitions in many ways, in that these elements or metals, materials are used for energy technologies and green technologies. But we see that the elements that have been used for these have changed considerably over time, shown in this cartoon from Zeff et al. 2014. Back in the 1700s, we used carbon for coal and peat for energy, calcium and iron to make things like windmills. By the 1800s, a larger number of elements were required to make trains, light bulbs, and by the 1900s, things really started to explode with automobiles, planes, and so on. That's when cobalt first became very important as a technology metal. And in the 2000s and moving forward, our list of these metals is increasing all the time. You can see from the bar chart that compared to what we call normal metals like copper, the amounts of technology metals mined is very low, but they're vitally important. And we couldn't make green technologies without them. So I'm part of a project led out of the University of Exeter called Met4Tech. This is a UKRI, Interdisciplinary Circular Economy Centre for Technology Metals. It's funded by the UK government, and it's a 4-year project set up to tackle how technology metals come into the UK, how they're used, and also thinking about the future. Within Met4Tech, we have 4 themes. One is to develop a virtual data observatory to look at the stocks and flows of various technology metals. Theme 2, which I lead, looks at circular economy principles for raw materials and new geomodels. Theme 3 looks at how we can better design, manufacture, and recycle metals, technology metals. And theme 4 looks forward, and how can we make a new technology metal circular economy system in the UK? You can see that a number of universities and educational institutes are parts of this. We also have 38 project partners who have pledged about £1.6 million of cash in in-kind support. So let's step back a minute and think about what circular economy is. Today, with many economies and many flows of different materials, we have what's called a linear economy. So if you take that diagram and you start at the top in the middle, you can see it says renewables and finite materials, and then there's some arrows moving down to the bottom. So basically that means you make these, you use them, and most of them end up in waste. What we want to do in the future is move away from a linear economy. So we want the circular parts of that diagram to become more effective. So the 3 basic principles of circular economy are to design so we don't have waste and pollution, or that we minimize those. We keep products and materials in use for as long as possible, and we regenerate natural systems. So within Met4Tech, coming back to that, theme 2 really illustrates how we're trying to implement circular economy from the raw material stage, right from the phase of getting the stuff out of the ground through to production and so on. And this is a schematic diagram to show what we're working on in Met4Tech. So we know in mining, we have a stage of exploration. Some projects are abandoned, but some go forward for development. And we might mine those, hopefully, but there might be resources that we still don't mine because they're uneconomic. That material goes to processing, and there is some waste generation. Moving forward, that material then goes into the manufacturing stage in industry. We take it to the industry, and the industry makes products and sells those on. What we're trying to do with circular economy is keep the 3 principles I outlined in the previous slide, reduce, reuse, and recycle as much as we possibly can. And so we're trying to take a cradle-to-cradle approach. We want to be able to get the raw materials out of the ground in the most sustainable, responsible way we can. We want to use the resources as much as we can. We want to minimize the waste that we're generating. And if we generate waste, we want to be able to use that waste for something else. We want to transfer value to the downstream industry, but also back into our mining chain. And then within industry, we want to make products that we can recycle very easily and get them back to the raw materials so we can start the whole circle again. One of the interesting things we're working on in Mat4Tech is something called responsible research and innovation. So we know that Mat4Tech and other circular economy projects involve creating new business models, new pathways of circulation, a data observatory, and new modes of provision. But within this could have unintended consequences, questions, ethical dilemmas, and social transformations. To avoid these unintended points, we do responsible research and innovation, RRI. And this is a long slide explaining what that is. Basically, it means that the innovators and all people within that circular economy chain become mutually responsible to each other. We want to accept, be sustainable, and take care of our society in the innovation process. We recognize it's a collective responsibility. The funders, the researchers, the industry, downstream industry, all affected parties, including consumers, have an important role to play in this. So I'm going to give you an example of the circular economy geomodel that we're working on at the moment, and I promise I am going to go back to Cobalt. So by way of illustration, what we're trying to do is incorporate what we do in geology with all of the principles within circular economy. So the Camborne School of Mines, who's leading all of Mat4Tech within the University of Exeter, is based in Cornwall in the southwest of England. Cornwall was, at one time, was a very important mining area for copper, tin, tungsten, and actually arsenic as well. And what we're seeing in Cornwall is a resurgence of interest in exploration for deposits that were either abandoned because it wasn't economic at the time, but also looking for new deposits with new types of exploration. And so what we do when we do this is we set up models like you see, the cartoon you see here. This is a 3D representation of the block of the earth showing Cornwall, and it shows a model of how the ore deposits in Cornwall are made. The pink are lithium-bearing granites, and within those granites, there's a lot of hot water moving around. That hot water is lithium-bearing, and that's one of the targets for new mine in Cornwall. Those hot waters also precipitate minerals with tin, tungsten, and copper in long veins, linear veins, and those are also targets. Within this, we've also imposed the legacy wastes and wastes that are made now, because we want to view those as potential resources, and also mineral sands in the seas offshore of Cornwall that have received tin mainly and other things from waste being put into the streams and also natural weathering. So that's our model, but what we're trying to do is work with our partners who are the mining companies to look at how we can take those metals out of the ground with novel extraction methods, how we can data and find all the data to put together to develop new models, to find the best way to do all of the mining work from exploration through to extraction and processing with a low carbon footprint, with low water use, and to build new business models, economic analysis, and to also look at our regulatory framework. Is there anything that we can do there to make circular economy work better? Imposing all this will create a circular economy geomodel, and we're working on that. We're about halfway through our work on this. So here's a map of Cornwall. The grays are our lithium-bearing granites, and we've put on with red outlines the areas of active exploration and mining on that map. And on the right, we've put the different commodities that people are exploring for, the companies are exploring for. So you can see it's hard to read the lighting, but the main thing is one that's mostly in red. That's geothermal lithium, right, with a bit of blue on the bottom, and tungsten as well in the center of Cornwall. So the center of Cornwall is one of the most active areas, but there are other areas as well. And you can see that the resource estimates for those elements, plus some other ones that are there, are very good. So circular economy means trying to get as much value out of your resource as you can. And that's why we're considering all of these elements. We've done some preliminary resource assessments, and we've classified these as our primary deposits. So what are the things we're going to dig out of the ground that have never been done before, but also bringing in the waste. This is one of the pillars of circular economy. How can we reuse and remine waste? And that's solid waste that's sitting on the ground, but also looking at mine water, because we recognize that there's a lot of water flowing through the old shafts from the historical mining that contains metals as well. One of the other things we want to do is consider not only the mining, but whatever else is going on. So are there competing and complementary resources? We recognize that because the granites are still cooling down, as they solidify, they're giving off a lot of heat. And so we can, looking at co-producing geothermal energy, heat and metals all at the same time. And also combining recycling and mineral processing, or metallurgical recovery sites within distance of all the potential mines. So that gives you an overview of the things we're doing in the lithium, tin, tungsten space. And I said I would mention cobalt, of course. So when we're finished our Cornish cobalt, or Cornish rather, geomodel, we're going to use our knowledge that we've gained from that and go on to work with the Cobalt Institute and other partners to try and develop another geomodel looking at cobalt deposits mined by large-scale mining and artisanal and small-scale mining globally. So our aim is to make a circular economy geomodel for global mining of cobalt from those two sectors. There's a lot to do with this, which you'll hear about at some point when we start working on this, but one of them is we recognize that ASM mining practices have not to date been considered in circular economy, but actually they do follow some of the circular economy principles. They exploit marginal ore bodies that would be normally considered as waste. They produce low amounts of carbon dioxide, and they can be socially important because you have a large workforce working in that sphere. The other activity that's part of Met4Tech involving cobalt is a PhD project that's being advertised at the moment, and that is assessing the circular economy potential of cobalt in the UK. It's co-supervised by people at the University of Exeter, the British Geological Survey, and the Cobalt Institute. And the two things they're going to work on are what you can see there, assessing and quantifying the UK anthropogenic resources of cobalt through stocks and flows modeling, but also researching and evaluating the business landscape for a circular economy cobalt ecosystem in the UK. So moving forward, there's a lot of work already been done on cobalt, and you're hearing about that during the conference. But within our project and others working in the sphere, we're trying to embed circular economy principles in cobalt raw material extraction, production, recycling as well. So thank you very much, and enjoy your conference.